So this is from topic 3.1, which we have just discussed. A question is, a wave passes through a gap in a barrier. The wavelength of a wave is same magnitude as the width of the gap. Like what they're saying, the wave is passing through a gap, the wavelength and the gap size are same. We have to tick one box to indicate what happened to the wave. You can annotate on the screen. Dispersion is like when a white light spread into color like violet, indigo, it's Vibgyor, violet, indigo, blue, green, yellow, orange, and red, we call Vibgyor. So here what will happen when a wave passes through a gap, the wave will spread out, and this spreading of the wave, what we call diffraction. So tick one box to indicate. So there will be diffraction only. Refraction is possible only if the speed of the wave changes. Like one side if of a gap or a barrier, if it was a deep water, other side shallow. Now, figure 5.1 shows six wave fronts which are traveling on the surface of a deep water. The wave incident in the region where the water is shallow. If I say complete a diagram, what will be the result? Moving from deep to shallow. So how it will look? So it will.
Away from normal.
So if this is a wave, this means that it travel at the same speed, but it will travel slower. So that's right. And if I say draw an arrow to show the direction, so the direction should be perpendicular. That's good. That direction should always be 90 degree because this black arrow is not making 90. It should be exactly looks like a 90. Okay. No problem here if you're not able to annotate with the straight lines, but I guess there's an option of drawing a straight line as well. So that's how it should be done. We move on to the next one. Yeah, sure. I will show. Now, if you want to show, just 1 minute, I will erase all the drawings. If they ask us draw the wavefront, so that's how we will draw. And all of you did good about drawing these wavefronts. Keep one thing in mind that spacing should be like uniform spacing. If they ask us draw a arrow to show the refracted ray, so the refracted will be perpendicular, so refracted will be like this, okay? If they ask us draw an arrow to show the incident, it's already drawn. Major, so we draw incident and a refracted and then draw a normal perpendicular to the surface. Because this is a surface, this is a boundary. So I need a normal. So it should be perpendicular. And the angle between the incident and the normal is angle of incidence. And the angle between the refracted and the normal is known as angle of refraction.
So should I draw the angle for the direction of the wave on the wave, or I should draw on the boundary?
On the boundary. On a figure, draw the wavefronts that we all did, where water waves travel more slowly. The next is the depth of a shallow water is now changed so that the speed of the wave is 0.60 meters per second. The speed of the wave in a deep water is 0.8 meters per second. The distance between the successive wave fronts is 1.4 centimeter. Calculate the wavelength of a wave in a shallow water. Remember,
Should find the frequency.
Frequency stays constant. Like if I take a if I first take a deep water in a shallow water, it was 0.6. In a deep water, it is 0.8. And the distance in a deep is 1.4. So first I will find the frequency. Frequency is the speed divided by the wavelength. But see, the speed is 0.8 meters per second and the wavelength is 1.4. So it should be,
1200.
we are talking about a deep. So it will be 0.8 divided by how much? 1.4 divided by 100, so 0.014. So what's the answer?
57.1.
So 57.1 hertz is the frequency of this wave in a deep. What will the frequency in the shallow? It will also have the same frequency. So again, we use the same formula that V is equals to F lambda. If I need lambda, it will be speed divided by frequency will be the lambda. How much is the speed? The speed is 0.6. What about the frequency? That is 57.1. What's the answer for the wavelength? 0.6 divided by 57.1. It will be a small answer.
0.01.
0.01. Only like this answer or
0.0105.
0.0105. So 0.0105
0.05.
meter. If I convert into centimeter, I multiply by 100, so 1.05 centimeter will be there. That is a wavelength. Look, whenever you see two, like a 4-mark question, it means two formulas should be used. There's also a direct method I will say. Whenever, we are deep in a, whenever we talk about a deep and a shallow water, so we can also use this formula that speed in a deep water divided by wavelength in a deep water will be equals to speed in a shallow water divided by wavelength in a shallow water. Because what is the ratio between speed and wavelength? Frequency. And what is the ratio between speed and wavelength? Also frequency. Like frequency in a deep and frequency in a shallow will be same. So you can also use this formula. V over lambda. And when you're using this formula, no need for even a unit conversion. You will get the ratios. Okay. So directly you can use, or you can also use first the frequency in a deep, then use that in a shallow to work out the wavelength in a shallow. Is it clear discussion? Anyone having a doubt in this? The next is figure 5.1. Figure 5.1 is a scale diagram of a wavefront of a red light approaches a gap in a barrier. Draw 3 wavefronts after a wave passes on the gap. What kind of diffraction it should be? Like it should be minimum or maximum?
Gap is 6.
So the gap looks, if the wavelength and the gap size look same, so it should be curve. And we have to draw 3. So using a compass, in exam you will have a compass and measure this length, and this should be same as this one. Yes, Hassan.
So shouldn't the wavelength be correct by eye?
Sorry, repeat. Should the wavelength be?
Like if we draw the diffracted rays
Right.
and the wavelength is correct by eye, is it right or do we have to measure it?
No, no. If the wavelength is correct by eye, that is also fine. Like if you draw a
Okay.
curve and it looks like, but sometime what happen when students are drawing, if you draw like this, so pattern is correct, but the wavelength is not right. So that's why. So it should either look same by eye when you're observing or seeing, or the simple rule is use a compass. Like just see this length is example 2 centimeter. So place a compass needle here, make 2 centimeter arc. Then make it 4 centimeter arc because 2 plus 2 will be. No, compass here. No need for change the position. Keep a compass at one position. You do first arc. Then you will draw the second arc 4 centimeter. Then you draw the third arc 6 centimeter. That's it. So even if it looks same as draw with an eye that it is same wavelength, you will score the mark as well. Yes, Ayad, you have any question?
Yes, sir. Sorry, I had the same question.
Same question, okay.
Sir, what if the wavefronts look distorted, but if we write that this is the same wavelength as the.
But this is a drawing question. So drawing question, it should look correct drawing rather than explaining. Like you write that it is maximum diffraction and wavelength is not changing, but the question is, let's see the marks as well, so that you will have a better idea. How the marks are distributed? The wave crest, same wavelength as original. Three arcs should be there, three curves and semicircular crest centered in the middle gap. Means should have a center. So it's like a more, because it's like a simple simple diagram, they're giving you three marks, so it means they want a precision as well.
Sir, what would be the direction of the diffractor?
The direction is always perpendicular. Like if this was there, then the wave which is diffracted,
Sir, but you said it should spread everywhere.
yeah, this is a spreading. The wave is spreading in all directions after the gap. But they did not ask us to draw direction, that's why we did not draw anything. The next is a figure 5.2 shows a same barrier and a gap, but a blue light approaches. So blue light, if you see the spectrum, the electromagnetic spectrum, which include violet, indigo, blue, green, yellow, orange, and red. Red is having the longest wavelength and violet is having the shortest wavelength. So if a blue light is there, it should diffract more or less. So what will happen to blue? It will diffract less because it has a shorter wavelength. So when we show, only confirm it. And it is a shorter wavelength. So another thing what it should appear, that this wavelength should be shorter than the previous one.
So
Okay.
should we draw the incident wavefronts as well?
I don't think they asked. They asked just a refracted one. Draw three wavefront. Okay, before it reaches the barrier. So if they ask, then we have to. So there are the three wavefront before it reaches the barrier. So I should draw.
They should have some.
Hmm?
It should be visible that they have a short.
Yeah, compared to the red given we are in the previous part, this should be shorter. And three after it passes. So this is a smaller diffraction. So you can just draw the straight line and make the edges bend. The next question three, figure 6.1 shows a wave crest and a direction of a travel of a wave approaching a barrier in a ripple tank. So this is a ripple tank, a wave is approaching, the wave fronts are there. You can annotate on the screen to answer this. The wavelength is 1.6 centimeter. On a figure, draw the direction of a wave of the reflected wave and the three successive reflected wavefront. How I will draw the direction of a reflected? Good. So first what I should do, I should draw a normal. That's right, Hashim. So and I will have this angle. Then
Angle of incidence equals to angle of reflection.
so I will draw angle of reflection. So this should be angle of reflection.
Three wave.
And the wave, but the wavelength should be same. Like example, if this is 1.6 centimeter, so this should also be 1.6 centimeter apart or look same. Okay. So that is what we have to do here in a reflection. Now, figure 6.2 shows identical waves approaching a barrier with a gap 1.3. What was the wavelength? 1.6. What is the gap? So it means what? It means the wavelength is greater. So how I should draw this? So what I should do? I should draw a circular wavefront. They ask draw three successive wave crests. So you can annotate on the screen how it should look like. How the wavefronts will look like when it passes through the gap. If it looks like this, you will lose the mark. So we want to show maximum, so means curve. And the equal space is this one, okay? The initial one. We move on to the next part. The frequency of a wave is 4 hertz. What is the speed? How to get the speed?
Speed equals to frequency multiplied by wavelength, 1.6 multiplied.
So V is equals to F lambda. The frequency is 4 and what was the wavelength? 1.6 centimeter. If the wavelength is in centimeter, 4 multiplied by 1.6, so it will be 6.4. And so yes, 6.4. So in that case, it will be 6.4 centimeters per second. Why? Because the wavelength was in centimeter. If I convert that 1.6 into meter, then I'll multiply, then my answer will be 0.064 meters per second. Okay. So if I am not converting, then my unit should be correct. Okay. Is it clear, this one? So 6.4 centimeters per second, you can also write, or 0.064. So this is about topic 3.1, which we discussed.